Hi, this is Kim, and this is my video response to problem set 2, question 3. Alright, in this question we are asked to use a hypothesis test to compare frustration scores for individuals classified as type A with frustration scores for individuals classified as type B. So here's our data, and let's see what we have to work with here. Alright, so we're asked to compare two separate groups. So I'm going to use an independent measures t-test. But before I can run that test, I need to make sure that I meet all the assumptions of that test. And there are actually 3, but the one I'm concerned with for this problem is homogeneity of variance. I need to make sure that the samples were drawn from populations that have equal variances. Meeting this assumption is going to be important in order to meaningfully estimate the standard error that I'm going to use later when I calculate my t-statistic. All right, thankfully, Herman Otto Hartley, in addition to founding the statistics program at Texas A&M, came up with a handy way to do this, the Fmax test. So let's run the data through it and see what we got. Okay, first I need the variance for each sample. Now it's not given, but that's okay, I can calculate it. According to the tattoo I got this weekend, variance is sum of squares divided by degrees of freedom. So let's do that for each of our groups over here. All right, for A we have 740, and we have 7 degrees of freedom. That's going to give us 105.71. And for our type Bs, we have 660, also divided by 7, which is going to give us 94.2. All right, let's put that into our Fmax formula. So we have the largest variance divided by the smallest variance. So let's put that right here. 105.71 divided by the smaller variance, which was 94.29. And when we divide these out, we get 1.12. Okay, now we need to know our critical value for our Fmax test. We need to know the number of separate samples, that's going to be 2. The numbers of degrees of freedom in each of our groups, so in that case this is going to be 7, and we need to know our alpha value, which we said is 0.5 for this test. And if we look it up on the Fmax table, we get a critical value of 4.99, which is significantly greater than the value we got of 1.12. Now that's usually not what you want to see in a test statistic, but with Fmax that's exactly what you want to see. So we have established that we have met the homogeneity of variance, and we are ready for our t-test. And the t-test was invented by William Gossett, who worked for Guinness Breweries. Coincidence? Probably not. Okay, so to set up my hypothesis test, we need a null and alternative hypothesis. Our question asks us to test whether type A personalities reported greater frustration than type B personalities. So that makes this a one-tailed test. Now, in one-tailed test, I think it's easier to write the alternative hypothesis first. So we're going to write that up here. We're going to say that the mean, in this case, of our first group, which is going to be our type A's, are going to have more frustration, so they're going to have greater frustration than the type B's. This is our second group. I'll call them, type B's. All right, now to find the null, I just state the logical opposite. So in this case, we're going to say that the type A's are not going to have as much frustration as the type B's. All right, very good. Now I need to find my critical value. To do that, we're going to know our alpha value. We said that's 0.5. And we're going to calculate the total degrees of freedom in 1 minus 1 plus n2 minus 1. So in this case, that's going to make our total degrees of freedom 14. All right, I use that information to consult my table, and we come down here and see that our 0.05, 14 degrees of freedom. It looks like we're going to get a critical value, oops, of 1.76. All right, very good. Now that we have that, we can go on and calculate our t statistic. So here's the rather intimidating looking formula. It's really not all that bad. I'm a big believer that inside of every big problem, there are a whole bunch of small problems trying to get out. And so I'm going to break this down, and I'm going to start with this denominator right here. Okay, this is actually our standard error, or estimated standard error. It's a calculation of how much distance is reasonable to expect between our sample statistic, in this case the difference between our sample means, and the corresponding population parameter, in this case the population mean difference based on the null hypothesis. And you can see here we have another small problem hiding in our big problem. The formula is asking me for pooled variance, the mean of our two sample variances. So we're going to need to do that. So here's the formula for calculating our pooled variance. And I have all these numbers from my data, so I'm just going to plug them in. I am getting the sum of my sums of squares. So let's put these up here. I'm going to divide that by the sum of my degrees of freedom for each of the samples. All right, and this is going to give us 1400, oops, over 14, and that's going to give us a pooled variance of 100, if I did my math correctly. Okay, so my pooled variance is 100. Let's go back and finish calculating our estimated standard error. I'm going to plug this in. So we've got our pooled variance of 100. We're going to divide by n, which is 8. I'm going to do it again. We have two samples. Divide by 8. Good. That's going to give us this, 12.5, square root of 12.5 plus 12.5. which is the square root of 25. So our estimated standard error is going to be 5. All right, now that we have our denominator under control, let's finish calculating our t statistic. Now we can actually write the bottom first because we know that our estimated standard error is 5. Okay, so let's look at this numerator. The numerator is asking me for the difference between the two sample means minus the difference between the two population means. But the null hypothesis state that there is no difference between the two population means. And so through the magic of Doceri, we can kind of just ignore this. All right, so now all we're left with is the difference between our two sample means, and we know what those are, so we can just put those in. Plug this in. Sample mean 1, right, and there's sample mean 2. Excellent. Let's make a little more space over here. Good, so we end up with this, then we just divide, and we end up with our t statistic coming out to 2.6. Awesome. Okay, now all we have to do is compare that to the critical value we got earlier. Remember, we got 1.76, and I'm not really sure where exactly it would be, probably somewhere over here. So we have 2.6, and as you can see with our t statistic over here, the chance of getting this value, if the null hypothesis is true, is less than 5%. And therefore, it is fair to say that we can reject the null. We have data that support a significant difference in the direction we predicted with only a 5% chance of being wrong. So, cheers. All right, that's it. I'm done. Thank you very much for assigning this. This was a fun problem.